Hello, class 11 students and Aggarwal students. Welcome once again to Math is Possible. So in the last video, we were doing some theorems. We're proving some theorems. I can see over here. I've done till theorem number 3, and now I'm going to start with theorem number 4. Okay, so let's begin. Theorem number 4. We take the book in my hand so that I have it with me, and I start with the theorem. So theorem number 4, everybody. Take out your notebooks and start writing. This is the fourth theorem. Theorem 4. Chapter Relation Functions. RS Aggarwal students. Class 11 students. Chapter Relations. Sorry, not functions. Relation functions for Aggarwal students. Together it is. You all have the chapter split up. Cbse students. Okay. So the fourth theorem is if A is a subset of B. Okay. If A is a subset of B, that's given, and then A cross A, is a subset of A cross B, okay, intersection B cross A. So A cross A, the values that we get in A cross A will be a subset of A cross B intersection B cross A. Now let's understand how it's going to be. Okay, so I'm going to start with the proof. So as I have already said, those of you who don't want to see the proof, don't see it. Okay. So let us take any arbitrary elements. Okay, since A is a subset of B, let us take A comma A, right? Let us take A comma A, okay, B, any element in A cross A, okay? A cross A, so we are taking A and A only because it's A cross A. So we are taking a coordinate or a point from A cross A set. Okay, so we can have like this. A cross A is, say, A cross A, yeah, B cross B comma B, yeah, C comma C, like that. So we are taking A cross A comma A in any element in A cross A. So we are going to start and say that, then let us start saying that A comma A belongs to A cross A, right? A comma A belongs to A cross A. Okay, which implies A belongs to A, okay, and A belongs to A. Alright? Okay. Now look, this first element A belongs to the set A, and the second element A also belongs to the set A. Basically both the sets are same. Okay. A. Now, since A is a subset of B, so we are going to do the same type of a thing. So this implies A belongs to A and A belongs to B. Okay, that's what it's given. Alright. So A belongs to A and A belongs to B. So now look very carefully. That implies actually, okay, this implies that this A, okay, belongs to A, comma, the A belongs to B, alright, and A belongs to B, comma, A belongs to A. Okay, look very carefully. Why? Because see, the A belongs to the A set and this A belongs to the B set. Then we can also write, and then this A belongs to the B set and the A belongs to the A set. So this way we are trying to get something like this. Alright. So now look very carefully. Now what happens? This means that A comma A belongs to A cross B. A comma A belongs to A cross B, and A comma A also belongs to B cross A, right? That means there is an intersection point. Look, and means intersection. Intersection means and. Okay, and union will mean as or. Always remember, when we are going to do questions on this, we will take intersection as and the union as or. So you see, we are getting an intersection point between A cross B and A cross A, B cross A, right? So this implies that A comma A belongs to A cross B. Okay, intersection B cross A, intersection B cross A. So that means this element, okay, this element which we had taken in A cross A, so which actually means the A comma A belongs to A cross A, and the A comma A also belongs to, okay, A cross B, intersection B cross A. That means this element belongs here and this element also belongs in this intersection of both of them. That means this part is a subset. This A cross A, okay, is a subset of B cross A cross B intersection B cross A. Okay, that means A cross A is contained over here. So in this last part, after you have proved this, what do you write? Simple. You write this part, what I have written, and then you write, so A cross A is a subset of A cross B intersection B cross A. Alright, and you have proved it. Okay, so that is okay. So what have you proved? You have proved since this is a subset of B, then you can get a formula like this, where A cross A is a subset of A cross B intersection B cross A. Alright, so if you actually get values A, B, okay, and if you actually do this, you will see it is a subset. Okay, you will see it is a subset. If you actually get numbers in set A, you get a few numbers, in set B you get a few numbers, such that the set A is contained in set B. Okay, so like that. Let's go on to theorem number 5. Okay, similar type of a theorem. So theorem number 4 is over. Next we go on to theorem number 5. So you'll write these. Those of you who don't want to prove it, just write these theorems 1, 2, 3, 4 like that, box. Okay. So fifth theorem. Theorem 5. Okay. What does theorem 5 say? Spun the clock to its mean. Theorem 5. So the theorem 5 is saying that for any sets A, B, C, so there are three sets given. For any sets A, comma B and C. For any sets A, B, C, okay, A cross B union C is equal to, right? Yeah. A cross B union A cross C. So those of you who don't want to see the proof, just make this as box. Write theorem 3. Write the whole thing. You want to write the whole thing. And that's it. That's it. That's enough for you. Okay. Now the proof of this. Now first of all, what you have to prove is very simple. A cross B union C. A cross B union C is A cross B union A cross C. So let us take an element. So the proof is let us take A comma B belonging to, let us take A comma B belonging to A cross B union C. Let us take A comma B belonging to A cross B union C. Okay, now look very carefully. So A comma B belongs to A cross B union C. Just hold on, let me see if you guys can see. Yes, you can see. Okay, so A comma B belongs to A cross B union C. This means A belongs to B. A belongs to B, and B and the small b belongs to B union C. Okay, this belongs to A belongs to B, and the small b belongs to B union C. So this, I told you, union means OR. Okay, union means OR. So A belongs to B and B belongs to B, or B belongs to C. Understood? Now when you split this up, this becomes A belongs to B and B belongs to B, or A belongs to B and B belongs to C. Okay, A belongs to C. You split it up like a multiplication. This into this, so this into this, this into this is into, and into this. Okay, or comes in the middle, that's a plus. Okay, so A belongs to B and B belongs to B. Then A belongs to B and B belongs to C, or A belongs to B and B belongs to C, and the OR is in the middle. So now what do you get? Now you get, very simple, the AND now changes to union again. So A comma B belongs to B intersection, changes to intersection again, B intersection, where is it? Belongs to A, it was, right? It was A, yeah, this was A, sorry, this was A. Just make this a slight change. So wherever you have written B, except for just this part, it just changes to A. Yeah, now it's okay. So A belongs to A and B belongs to the union of B and C. So that means A belongs to A and B belongs to B, or B belongs to C. That means A belongs to A and B belongs to B, A belongs to A and B belongs to C, or A belongs to A and B belongs to C. Okay, so first is for this part, A belongs to A and B belongs to B, or A belongs to A and B belongs to C. Okay, now A comma B belongs to A intersection B, A intersection and A, that will change to cross. Okay, in A cross B, because this is a coordinate, that's not a set. Okay, or changes to union now, and this becomes A comma B belongs to A cross C. Okay, so we get two paths now. We've got two paths. Then we can write this as A comma B belongs to, okay, A cross B union A cross C, like that. Okay, so we've got the formula over here. So now we have started from A comma B belongs to this. So A comma B also belongs to this whole set. So now what you can write? You just write it on top that. So A cross B union C is equal to A cross B union A cross C. So that's theorem number 5, and we are done with it. Okay, so let me just tick it off. Theorem number 5. So how many theorems we are left with now? 6, 7, 8, 9, and the last theorem 10. So we have done. So let's do. There is another way to prove this also. No need. You can use distributive law and prove. Without no need, you can use this also. Distributive law is also nice and easy. If you want, I can try that. But then I don't want to confuse you with again and or and all. So go on to theorem number 6. So let's go ahead and do theorem number 6. Okay. Let's go ahead and do theorem number 6, students. So this is theorem number 6. Theorem number 6. What is theorem number 6? Theorem number 6 is saying for any set A, for any set A comma B comma C, for any set A comma B comma C, A cross B intersection C is equal to A cross B intersection A cross C. Okay, A cross B intersection C is A cross B intersection A cross C. Okay. Now look. Now so the proof is, how will it go? Same way, A comma B belong to A cross B intersection C. Okay. What does this imply? This implies A belongs to A and B belongs to B intersection C. Right? Split it up in two parts. Yes? Yes. Now, next part, what does it imply? A belongs to A and B belongs to B and B belongs to C. Correct? Look very carefully. The union changes to and sorry, not union, intersection. INTERSECTION, intersection, and union changes to or, and also the multiplication changes over here to the and, the cross. Okay. So now what does it happen? So now you can write A belongs to A and A belongs to B. Sorry, B belongs to B. Small one. This one here. Put an and over here. There's an and here also. So A belongs to A and B belongs to C. So now what happens? This and changes to cross. So you write A comma B belongs to A cross B and A comma B belongs to A cross C. Okay. Now what do? The next part implies, see, so you got it. So you write just A comma B belongs to A cross B intersection A cross C. Why? The and changes to intersection back again. Okay, so now you have started from here and you got this. So you have proved it that this is equal to this. So you can write A cross B intersection C is equals to A cross B intersection A cross C. Okay, students. So that's your theorem number 6, and that is even done. Okay, I have the pen in my hand. So in the next video I will do the last 3 theorems, finish up the theorems, and we will go on to the exercise number 2b. So you have to prove these things. So those of you who are watching the theorems, the proof of the theorems, you will have to use these proofs only to prove them, because there is an exercise in 2b in this chapter, relation, where you have to prove a few certain things that are given over there. Okay, so we'll do that and then we'll continue with the chapter. Very nice chapter. Okay, so that's it for today. Please continue watching my videos and take as much help as possible from my channel and your channel, Math is Possible.